Good morning, good evening, good afternoon, everybody, depending on where you're joining us in the world today. Welcome to Immersed, our new monthly seminar series sponsored by MIT.nano, exploring how immersive technology and new modalities for manipulating, visualizing, understanding data in engineering and science and art are impacting those fields together and by themselves. In the Immersion Lab at MIT.nano, we provide space and tools and a platform to allow artists and scientists to explore new technologies and new modalities of interacting and creating data. Today, it's my great pleasure to have with us Eric Paré, a bullet time and light painting photographer. Eric's work combines photography, travel, and light painting. Travels around the world painting with lights, mixing light painting, landscape photography. And today he'll share with us some of the exciting work that he's doing in combining hundreds of DSLR cameras and providing 360-degree views of some phenomenal topics. Eric, thank you very much for joining us today. I look forward to your talk, and I look forward to our continued work together to get your experience and your technology embedded into the offerings that we provide in MIT.nano in the Immersion Lab. Eric, let me stop sharing and take it away.
Hi, Brian. Thanks for the introduction. So this is what I do, 360-degree bullet time light painting. And we'll go through a lot of the history, why I do that, how I do it. So this picture is from a very recent shooting. This is my actual studio. And you can see me holding my usual light painting tube just before making the shot. And just so there's no big surprise, here's what the result looks like for that kind of shot that we're doing. So it's not 3D, it's just images stacked one after the other to create a movie. What I'm going to cover today is multi-camera installations, including the hardware, the software, and long exposure. So I'll go a little bit more in the technical side of it, more than I'm usually doing. But also I'm going to talk about 3D scanning, volumetric capture, and bird watching. So my background is a software developer. I've been coding since I was probably 12 or 13. This is a big part of my life, but I'm also a bird photographer. This is what I was doing actually before starting this bullet time adventure. So I was traveling the world with a camera, just watching birds and taking pictures. And what a bird photographer software developer usually turns into a multi-camera expert, something like this. I know it's a bit weird, but the thing is that as I was a programmer and also a photographer, I've been hired to do that kind of gigs a long time ago, to connect a bunch of cameras together and to automate everything to get MP4 ready within a few seconds. So I started in Montreal. This is where I live. In 2011, so I'm celebrating my 10 years doing this. This year, it's a celebration. And I started with only 21 cameras, which was a lot back then because it was so complicated. Like we're talking like 10 years ago, there was nothing on the market to connect multiple cameras. There was no instructions online. There was no hardware. It was just cameras and hoping for the best. So I started to code my first multi-camera thing back then, and using only 10 to 28 cameras. Not making any art with these cameras. It was only about making people jump, having fun in summer music festivals. And so you can see two examples there, one with only 16 cameras and the other with 10. So everything was kind of automated, a bit sketchy, but there was no digital calibration. So each of the camera had to be placed by hand with precision, and we were hoping that nothing would move for a whole day. It was very stressful to make these events. I'm glad that things have changed. And after about a year or two being on the road with these systems, I had the occasion to slow down a little bit, spend some time in the studio with 24 cameras and experiment to see what I could come up with, something that would be a bit more interesting than just making people jump. And so this is my first light painting picture. You can laugh. It's very, very bad, but I was using just a bicycle, real light, a red light. So I just drew around that person, and that was the first result. And I was super happy with that, but I didn't know where I could go from there. So what happened is that as I had such a small studio, I had the hard time making good studio photography because all of the cameras were visible if I was using strobes or any source of light. So the best thing I came up with was light painting. So it was kind of by accident that I started to do light painting. It was just a way to light up my subject in the center of the frame without revealing the cameras. And that's one of the best examples I created from my early work, where I was lighting up all the frames were lit up in only 1 second, and I was repeating the same movement again and again. And so I worked probably for 2 years just learning light painting, the studio, crafting my style, and doing less of work on the road really helped me to define the future of what I wanted to do with this technology, because it was fun to make people jump, but I wanted to bring it to a level where I would be happy with the end result, to make it something a bit more artistic. And so light painting has been there for forever, probably since the beginning of photography. But the way I wanted to use it was without any flash and having a crisp subject. So what I found out is that if I was using a very bright flashlight and a very short exposure, so with only 1 second, I could come up with very crisp images. And that's a good example from my early work. In only 1 second, I created this video with 32 cameras. So I just pressed my trigger button, hold it for 1 second, did the light painting, release the button, and that created that small video. But that was not enough for me. I wanted to bring this outdoors, not the whole camera array. I just wanted to make it more simple. I wanted to bring the light painting part outdoors because I've been a traveler for a long time. So I wanted to just go with a backpack, a single camera, and do light painting outdoors. But it took me so long to find out how to get that quality outdoors, because the tools that I was using in the studio were super small. And what I figured out after over a year was that I needed a very long tube, and that was the key. So that super long tube that I'm holding here is what I've been working with since 2015 now. So it's been a while, and that's the kind of images we create. So this image is from my first session with the long light painting tube, and it cost me only $2 back then because it was just a plastic cover tube used for fluorescent lights. So I simply put a flashlight inside of the plastic tube, I waved it, and that created that image. So I was quite stoked when I saw the result, and I knew I was into something. I knew that I found the right tool for what I was looking for. And I've been traveling forever since then using the same kind of tool. So this is much more recent, using more fancy stuff on top of the tube and sparklers and mixing with feathers, playing outdoors in the desert in Morocco, mixing with also with star trails. And so in Chile with the Milky Way, so this is not Photoshop, it's all made in camera, 8-second exposure, single plastic tube, and make the circle by hand. And that's about it. So I'm gonna go a bit closer to this. So that's a typical light painting tube, just a plastic tube, in which I put a flashlight, I turn it on, so it's bright enough to make light painting behind the subject. So I've been trying for a while with single camera to do my outdoors light painting work, but also with tons of cameras for different reasons, mostly for advertising stuff or photo booth. So this is a typical 60 camera array. This one is in Sharjah, UAE. It was in 2018. And you can see the outside on the top image and the inside on the other one. And on the top image, you can see that we have two playback TV that are showing the result in near real time. We also have two sharing stations on the left side, so folks could share their videos right away. So we would just see one person after the other doing the light painting, and they were able to get these videos kind of a souvenir. And similar thing, but this one with only 24 cameras. This is at CES 2019 with Canon. And so they built that black box for us, and we did real-time light painting using those 24 cameras. And that's the result you can see on the right side. And by doing these events, that forced us to improve the software, of course, because when we keep pushing the technology to make it faster, smoother, and also accessible for other people. So we're selling the software to other agencies that are still doing by-time photography, mostly for a photo booth like this one. So here's another one in Atlanta, where we worked for Microsoft with 2 stations of 42 cameras. And this one is 2016, I think, and by that time we had a solid team, very good software. We had digital calibration, which was really helpful, because back in the days with 21 cameras, it was okay, it was hard, but it was possible to align everything just with the high side. But with 84 cameras, it's just too much. So we needed digital calibration. So my team worked on that, and a lot of improvement have been made to the software to make everything faster. And now this is what my studio looks like today in Montreal using 176 cameras. So I took a couple of good shots of the structure itself recently, because I like to do that also, not just take pictures of using the structure, but pictures from the outside. And the equipment on this one is a 176 Canon SL1. They're starting to get old, but if you think about it, it's not too bad, because these cameras have been on the market for, I think, 8 years now, but they can shoot at 5K resolution each in RAW. So even today, it competes with the high-end video cameras. So as I can get a RAW file at 5K from each angle, in the end, it's a 5K video that I can output, which is not too bad for a camera that is that old. But as we all know, a photo is always better quality than a video. So as I'm taking pictures with these DSLRs, I can get a very good quality, even if it's a super old camera. I'm using 44 Raspberry Pis 3D Plus on this structure. And the reason for that is that we need to transfer the files super quickly. And the bottleneck on that kind of installation is the USB 2 connection from the cameras. And there's no way around it. All of these cameras, even the newest ones from Canon or similar, are all USB 2. The ones that we can control actually are all USB 2. So the trick to make everything faster is to distribute the download using Raspberry Pi. So each Pi has 4 cameras connected to it. And the Pis are going to network switches. They're all gigabyte network switches. And then to a main router, to a main computer that is crunching the data, calibrating all the files, and making an MP4. So it takes 12 seconds currently to shoot in 1080p, which is quite nice. That's 12 seconds to get all of the files, to calibrate them, and to create an MP4. So we've been a long way, like since the beginning where it was taking minutes, now it's just 12 seconds for this. But in the studio, I shoot in RAW, which takes a bit longer because it's a lot of data. And we're at, I think, 55 seconds currently for a full data set of 176 RAW files. And that is the software that we're working on. It's all made in-house here by my team. I don't code anymore. I've retired, or I've been fired actually from that, because I'm mostly testing the technology, talking about it, teaching about how to do multi-camera work. But my team is really good at working on the software to make it always faster and more intuitive to work with. So the base idea was to make something similar to the back of a Canon DSLR, where you can just touch on the tiles and change the settings from there. So everything is touch based on the software, also network based. So that means that we can have different tablets or computers, and we can connect through a web browser to access all of the features from any device, including smartphone or TV. So you see on many of my videos where I have 2 tablets, 1 big TV, 1 smartphone, and it's all network connected, so super fast. No Wi-Fi, obviously, because it would be a bit slower, but we just connect everything by Ethernet cable, and everything is super fast. So as you can see on the close-up of the software interface, I have a big trigger button, and I can go in live view, can focus the cameras from the software itself. I can change usual things, the aperture, the shutter speed, the ISO, the image format, so many settings that are available, including the trigger mode, the thing at the top, where I can decide to either trigger all the cameras at the same time or one after the other at a specific interval. So in that case, I ask for 117 millisecond interval. That's the time, the triggering between each camera. And let me just go back here. Okay, so, and I can also do jump and freeze, where half of the cameras are going to trigger an interval and then going to freeze the remaining camera. So it looks like jumping, and then you're frozen for the rest of the triggering. And we can also do custom trigger sequence, like send any sequence to trigger any cameras at any moment. We can build the sequences in Excel, paste that to Xangle, to the software. And the software is going to handle the sequence, going to send the recipe to all of the Raspberry Pis and then to the cameras at the moment we click on the trigger button. And I made a quick video to demonstrate the speed of the whole thing. I'm quite happy about this one. I made it last Sunday, I think. So in 1.7 seconds, I have 2 preview frames. So this is frame 1 and 88. And then in 12 seconds, the full video is available. This is my happy face. But that was not light painting. We also shoot, like freeze the moment. We do a lot of other things, but my typical light painting work using 176 cameras looks like this. And what's interesting about this one is that the light is moving. That means that I did not trigger all the cameras at the same time. She's not moving, but I'm moving with the light, and the cameras are triggering one after the other, and that's creating the movement in the light. Same thing on this one, but it goes a bit slower on this one. I recently started to work with AI interpolation, and sometimes works quite well. So on this one, I have 8 times 176 frames. So that's why it looks so so smooth. We can see some glitches from the interpolation, but if you guys know other ways to interpolate, you know that this is quite good with the current state of the technology. And this is another demo where I'm going to go the whole process, including the light painting. So I press the button for the smoke machine. I have that on my belt. Then I test the light on the subject. And then I'm going to press the trigger button. I do the light painting, so 3 passes. I turn on and off the light 3 times. Press the button again to end the exposure. And that's a close-up on my tool. And then we're going to see the result. And this is without editing. This is how it came out of the system. I accept the zoom in, of course, but the end result was really like this. You can see my face a little bit if you look at the right side, but that happens sometime. And going back to bird watching, that's a very recent shot. It's not online yet, but here we go. We work with real birds recently and quite stoked about this one. So that's going to be released probably tomorrow or in 2 days. We had 5 doves in the studio. I think there's a bunny also somewhere on this picture. And I talked about mostly by the time light painting. We do a lot of other things with these cameras, of course, and with the software, with that kind of technology. We're always interested to dive more into what's possible to capture using different devices, to capture the time in different moments and to capture different ways also. So we also work with PyCam, which is a very low resolution, low quality, but low cost way to do bullet time or photogrammetry. So on the top image, you can see 4 PyCam V2 cameras that are all connected through Raspberry Pis to the same software, always working with X-Angle camera server. And same again for the other image at the bottom, where you see 12 Android smartphones. And these are very inexpensive one. I think that I paid $149 each. These are Moto G7 Play, something like this. So it's getting very cheap now to do multi-camera work using these devices. Of course, it's never the same quality as the DSLRs, but it's a good way to get started. There's no way to freeze the time as we do it with DSLRs when using PyCam or our smartphones, but we're getting closer slowly. It's mostly about the fact that these devices are filming, and what we need is really to take pictures. So DSLRs is always the best option to freeze the time and to get good quality. But still, it's nice to be able to support these different devices. So it works with most Android phones, version 8 or more, something like this. So we have a lot of the documentation on the website. And then a big part of my business is photogrammetry. So what you see there is a studio right beside the bullet time. I don't have enough cameras to do both at the same time, but I have enough electronic components. So we just switch the cameras from one station to the other when we need to go from bullet time to 3D scan. So this is the head scanner. And we also have a full body scanner. And what you see at the bottom is the end result of a face scan. This is something we use for the gaming and cinema industry. So clients are going to send us talents or actors, and we're going to scan them, and they handle the post-production. I'm not handling too much that department. My team is taking care of this. I'm not as much interested in that because there's a lot of post-processing involved, a lot of cleaning of the 3D models, which I'm not doing. But it's the same technology, the same cameras, the same software, the same hardware. It's just that it's configured differently. So with bullet time, I need everything on the same plane so we can have a beautiful playback loop. But with photogrammetry, the idea is to capture from all angles, close up of each part of the face or the body to make sure that we have a lot of details on the actor. And so we have cameras on top, we have cameras at the bottom, trying to cover all angles. But when we press the button, it's the same thing. All the files are going through the network to the main computer. And then this is the delivery. This is what we send to our clients, only the raw files, and they take care of the rest. And you can see more info about that on xangle3d.com, which is the website about this specific service at the studio here. Now, we've been asked so many times about volumetric capture. The thing is that it doesn't work with DSLRs because there's no way to genlock the time, and a clap is not good enough for this because the
Eric, sorry to interrupt. Could you briefly describe what volumetric capture is?
Yeah. So when we do photogrammetry, we're taking pictures from all angles, and that creates a snapshot that can be used to create a 3D model, not animated at all. So to animate a 3D scan made with photogrammetry, you need to rig it. So there are softwares to do that. It's outside of what we usually do here. But with volumetric capture, you add the notion of time also. And that's more complicated. That's a lot of data. So Intel had a huge studio. I think they closed it recently. And it's very complicated technology because there are not many cameras available on the market that can be good enough for this. It's not about the quality of the sensor, but about the fact that the cameras need to be gen-locked. So the frame rate is the same on all of them. So by capturing video from all angles, then you can recreate a real 3D capture of your subject. So for something like AR, it would be perfect. The actual way to do this on a budget is to use Azure Kinetic. This is the right technology for very low resolution, and you don't need many of those because it has a depth sensor. In our case, what we're trying to achieve is to do everything using only cameras. So the ones that we know that we can genlock are this is the PyCam HQ, but even out of the box, you cannot genlock. You have to make some electronic components and cables to connect all of them together. So this is work in progress for us. Okay, so my goal with this, with the volumetric aspect at the business here, is to make this technology available the same way we did it with photogrammetry and bullet time. Xangle Camera Server, the software we're developing, is now used by so many agencies, companies around the world to handle from 6 to 200 cameras. And you can handle all the steps, including like the camera settings, the file transfer, the backupping. There are so many things built in inside the software to make your life easier with everything about multi-camera work. And we want to bring the same quality, the same kind of software with volumetric capture. So this is a very long-term project for us because at that point there's not much available in the market. the most affordable solution, the most affordable cameras we could find is the PyCam HQ, but it still requires some electronic components. So our ideal it would be to just get one camera like a GoPro, and you connect it, and that's part of your volumetric capture system. So we're still working on it. We'll see where the future leads us with that. And I talk very fast. That's it. That's it for this one. I guess we'll have a lot of questions. If you want to know more about the bullet time or the photogrammetry thing, I have the links on the screen now. So if you go on my website, ericparé.com, you see everything about the technology, the software, the hardware. We have pages about that explain what kind of hardware works best for which situation. We have a page which compares what's best between DSLR and smartphone. And also everything about the light painting tubes. I didn't go too deep into that today, but we build all of our tools here for light painting at the studio upstairs, and so you can get all of those fancy, colorful light painting tubes on the store. So this is lightpainting.store.
Eric, thank you. I sent you the virtual and the physical applause. Very fascinating work. Very, very interesting. So participants, please feel free to chat your questions. I also, let me just take the host prerogative and ask a first one. I think one of the areas that I'm very excited to work with Eric about is indeed on the volumetric work applied to like motion capture and science and engineering applications. But the question that I have, Eric, have you thought about sort of the timing, obviously, of the cameras, but the timing of lights? Like, how do you sort of incorporate either the motion of the light or the timing of the light, either to augment the artistic capture or to use that as a time reference for how you collect and aggregate your data?
Yeah, so about the time reference itself, like usually it's a clap in cinema, which is enough for anything that is cinema with 2 or 3 angles. For volumetric, it's not enough because at 24 frames per second, you need all frames to be in sync. So even your clap is not going to be precise enough if you have something that is moving fast. So that's why you need to gen lock all of the cameras. Now about the artistic part of it with volumetric capture, I have no idea. And actually, I'm not that interested in that part yet because my head is really like bursting with ideas about the light painting in bullet time when it loops in a perfect circle. So I'm not that interested to go around my subject in a more like a typical volumetric or photogrammetry capture. We'll see later, maybe we're going to go there. I'm starting to think about it, but at the moment I have this story that is so amazing and I have access to it on a daily basis with 176 cameras. So this is really what I'm into these days.
Great, thank you. This is the question from Ali, just asking, I guess, he's asked about the commercial applications, but I'll rephrase that. Some of the technical applications where you're mixing with other sensory information, whether it be LiDAR, and then maybe some of the larger applications, like in the areas of construction or buildings or spaces, and not just subjects that are inside of a space.
Yeah, so that would be a different way to place the devices. Like with construction, you put your LiDAR or like this volumetric capture thing on one side and go in one direction. And that would imply the similar technology. But what I'm into is really about having a bubble and capturing a live subject inside of it. Because with everything that is not moving, let's say you want to scan an apple, you probably already know that you just need one camera and you take multiple pictures of it. In our case, the idea of having that many cameras, either with photogrammetry or volumetric capture, is to have a live subject where we can scan either the motion or just a snap a moment where the actor doesn't have to stay still. Because for those who have already tried to do a 3D scan of a human, it's really hard to stay still. And you have a hard time to get a clean 3D render out of that. And that's why we're using that many cameras. So so about this question for construction, it's not really our kind of things, but for medical purpose, that's very different. Like, so let's say you need to scan a hand to make what's the word for that? Prothèse in French. Can you help me with that?
You mean fast? You mean?
Just something to help with maybe your foot, your hand. So in the medical world, there are so many applications that we can work with. But for anything other than that, we're not thinking too much about that at the moment, because we're focused on capturing what's inside the bubble of cameras. But what's interesting about the fact that we're now getting bigger and bigger in this field of photogrammetry and volumetric capture is that we get requests from companies to use the software in different ways. So for example, multi-camera time lapses, multi-camera scans of objects with many cameras on a rail that is moving, doing focus stacking at the same time. All handles from our software, not an idea from us, but it is supported because it's just part of the whole thing where you can sync multiple cameras together. So there are many commercial applications, but maybe to be clear about this, what's paying the bills for us here is mostly scanning actors, doing gigs for brands. So we do content creation and the software itself. So there are so many photogrammetry systems now that are running using X-angle camera server, and that's helping us to get better also because some of these clients are going to ask different ways to trigger the cameras, to have groups of cameras. So we keep improving the software, and we hope to go bigger in that area mostly.
And I think you'll find, certainly as we look to work with you, getting some of these science. We're very excited to push on the scientific and engineering applications. That'll be exciting to expand beyond where you're currently pursuing your commercial interests.
You want to?
There's a question, a hand. Let me see. Let me go to the audience real quick. There's a hand raised from the individual named E62-250. So I'm assuming that's building E62 on MIT's campus, room 250. But you can go ahead and ask your question.
Hey Brian, thanks. We had a couple questions for you if we have the time. First question is, we're really interested about the lighting. We're just kind of figuring out, we're just kind of thinking through how that might work. Is there anything you can tell us a little bit more about that? We came a little late, we may have missed that. Like, are you guys using flash, or is there like static lighting?
So for the light painting work, you mean?
Just for like lighting the subject other than just like with the light painting rod, because I'm seeing like that device that has like, I'm assuming it's like kind of like a pixel stick on like steroids, but like something more like just for like, okay, so, you know what I mean?
So that pixel stick on steroid is just a plastic tube. Okay, so a pixel stick is probably $200 to $300. This is probably $20 or $30, and so it's colorful. But I just put a flashlight inside of it, and that's the only source of light. I don't use a strobe. I don't use any other source of light. It's just this thing. It's powerful enough to light up my subject. You cannot really see it because my studio lights are so bright, but this is very bright enough to freeze a subject if I go fast enough. So that's a technique by itself, just doing the light painting in 1 second to freeze your subject. If you want to know more about this, I have a lot of tutorials about the way I do light painting. Just go to Tube Stories. Can I type that in the chat? Yes. So on tubestories.tv, I have 200 videos talking about either light painting tools, the way I use the tubes, light painting in 360, in studio, outdoors, traveling with this. So it's been my life for many years now. So I love to talk about that, make conferences about how I use the tubes. So this is the only source of light, that light painting tube.
Interesting. That's awesome. Thank you for that. We definitely will check out those videos. Second question that we had is there a specific reason that 176 was chosen? Was that like kind of like restricted by like a budget? is there like, plans to maybe expand that to like, a more, like kind of fine resolution of like maybe 360 or whatever the case may be that would be able to yield like even more divisions of that? Or is that just kind of something that worked out with like hardware and budget?
Yeah, and I see that GF also has the same question. Bonjour, GF, by the way. So 176 is my physical limitation currently because my studio is just not big enough to go any bigger than that. So I have the limitation of my walls and the limitation of the size of the camera itself. They are so close to each other that I cannot put any more than that. So that's my current limit. But also, I don't want to mix camera models. And this specific model, the Canon SL1, is not available anymore because it's too old. So I need to, if I want to go bigger, I need to get more of those. And actually in Montreal, if I see that one SL1 is available on the second-hand market, I get it right away because they're getting so hard to purchase now. And sometimes if I have one that breaks, I need to replace it. So I try to buy as many as I can, but it's only like one per 2 months because they don't exist anymore. So the next, what would be more interesting for me is to have more cameras on the same configuration, so smaller cameras. So the PiCam HQ is much smaller. So these I could put probably 300 on the same rig. That would be better because more cameras means slower playback, and that's interesting. So then I can really slow down the time, and I don't have to rely on tricks like interpolation to make my videos slower.
So we probably have time for maybe one or two more questions. Let me just take a strategic one here. There was a question from a participant. How do you ensure that your body doesn't occlude the image or the human subject while you're moving in the scene to do the light painting?
I move fast, that's a trick. So two things, I'm wearing black clothing, and yes, I move fast, but also, so on this tube right here, you can see that the light is going in one direction, but the other part is black. So I don't have any light hitting myself. So that's a very important trick. It took me a while to figure that out, but now I don't even have to wear long sleeves. I'm not visible in most of my shots. My shadow is going to be visible in so many of my pictures. I live with it. That's how it works. I just cannot, I could use the arm on the ceiling to do the light painting, and then I would be invisible, but I wouldn't be able to make those fancy shapes, and I won't have a job. So I prefer to do the light painting by hand. This is the creative part of my work. So I'm okay with the fact that my shadow is visible, but I try to make my face invisible. If it gets visible, I just throw out the pictures. So you don't see myself in most of the shots because I throw out the ones that are bad, but yes, I get visible sometimes.
And then Praneeth, I think you had a question. If you want to go ahead and take the last question, and I'm going to bring up the slide for the coming discussions.
How far are we from taking locked videos from DSLRs with your X-angle software? I know you're working on volumetric capture with Raspberry Pis, but is there a limitation in terms of DSLRs, or is it mainly the cost?
The DSLRs that are on the market, actually, like any Canon, Nikon, Sony cameras, the one that are like available to purchase at a decent price, they don't have mirror lockup. I'm sorry. I'm gonna start that again. They don't have gen lock, and that means that you cannot sync the frame between all of the units. And this is something that is absolutely required for volumetric capture. So the best option at the moment in the good quality sensor is the Zcam E2, but I think it's $2,000 per unit, and it's just way too much to build a full volumetric capture using this. But that would be the best option at the moment if you need really good quality. There's just no way to gen lock the video on any of the actual cameras on the market. Maybe like a Canon C300 has that. So like or some red cameras, but this is so expensive and you need to cover a lot of angles. So it's not really an option at the moment, except if you're shooting like a high-end movie, probably, but this is not the market I'm in at the moment.
Right. Thank you.
Again, Eric, thank you very much. And as I think maybe everybody knows or does not know, we have a photogrammetric system in the immersion lab at MIT.nano, and we look forward to working with Eric to get the X-angle software and tools incorporated in pushing the science and engineering aspects. So again, Eric, fascinating work, and thank you for your time today.
Thanks a lot, Brian.
And then next month, we'll have our next on Immersed, will be Immersed in Medical Imaging. Looking at the novel ways of both acquiring, interacting with, and visualizing medical data, medical imaging data. So that'll be on June 23rd, and then following will be Immersed in Music, and July 28th will feature also a live performance. So thank you everybody for joining us today. Everybody stay safe. Eric, again, fascinating work, and thank you for your time today, and be well.
Thanks so much for the invitation. Talk to you soon.